Hi. Hi, this is Dr. Wallace. I was going to do some problems from ALEKS for you. Give it a shot. So this first one says, Money Savers Bank offers a savings account that earns 7% interest per year, compounded continuously. My deposit's $3,200. After 2 years, what will her amount be at the end? Well, there are two formulas for the amount of a account that accrues interest. First is the regular compounded interest formula, which is P, which is the principal, which is the amount invested. So that would be this number here, this time, times the quantity 1 plus R over N. R is the rate, N is the number of times we compound per year, T is the number of years. But this is compounded continuously, right? So that's using the other formula, right? Because continuously means that N is infinity, and we can't really plug in the number infinity right there. So this is just a easy plug and chug kind of question here. And let me see. Let's get our calculator out. It can. There it is. Okay. So we're going to be putting all the numbers in we know. Okay. So that would be A, which we don't know, 3,200, which we do, then E, which is a number that's in our calculator, R, which is 0.07, because that's what 7% is as a decimal, times 2, and all that has to be in our exponent. So we would go 3,200 e to the power 0.07 times d, and you get the answer, and you round to the nearest penny. So here the answer would be right size. There we go. 36.80 and 88 cents. Okay, but what happens if you would have a it's not compounded continuously, but compounded annually or daily or quarterly or some other type of compounding period? Then you use the regular compounded interest formula. And each problem will be a little different, right? Here, compounded annually means that N is 1. If it said semi-annually, then N would be 2. Quarterly, N would be 4, and so on. Okay, monthly, 12. You get it. But bottom line is, this is another one of these where we have to just plug into the formula. It's really an easy one. So here, A is 2 G's. R is 0.135, because that's what 13.5% would be as a decimal. N would be 1, and T is 5. Okay, so be careful. Some of these problems will be different, and they'll give you the amount, and then you'll need to find the number of years or other things here. The N will be different. Okay, you got to read carefully, but these are the most straightforward ones. These are the ones that I see that you are ready to work on right now, generally as a class. And, you know, depending on the operating system you have, you may need to put parentheses around your exponent. Make sure you don't make an order of operations mistake. Okay, this one, the answer's 37.67 and 12 cents. Be warned though that if you get an answer like, I don't know, 3 million or something for a loan that you put into $2,000 for 5 years, that's got to be the wrong answer. Okay, so you made some mistake when you plugged in to your calculator. All right, so what if we wanted to solve, say, for the number of years? Say we wanted to figure out how long it would take us to get to $4,000, right? So another type of problem would be like, oh, I really want to earn $4,000, so the amount would be 4,000. In other words, that would be how long it would take for my investment to double at this interest rate, right? Compounded annually. Well, now the unknown number is t, right? So we have to solve for t. That means we need to find a way to undo exponential functions. So like if we divide both sides by 2,000, we get 2 equals 1 plus 0.135 to the t. We need to be able to get the t by itself somehow. And so that's when we need to use logarithms. What is a logarithm, right? So here's a question where you might have to do that, right? So we need to solve this equation. And to do that, you have to use logarithms to get the exponent by itself. So a logarithm has the property that log base a of a to the x is x, or a to the log base a of x is x. So a logarithm kind of cancels out an exponential. So if we want to change this thing so that we can get the y by itself, what I would do is I would take log base 6 of both sides. That's one way you can think of doing this. Okay, there's other ways that are probably described in ALEKS. Just switching to logarithmic form is another way to think about this. But the log base 6 and the 6, they will cancel each other. And so what's left on one side is just y minus 8. Okay, then now we can just solve for y. We add 8 to both sides, so we get y equals log base 6 of 7 plus 8. Now, this log base 6 of 7 is just a number. Now, your calculator, based on what kind you have, might allow you to do that. But most calculators and the ALEKS calculator do not have a general base. So you have to change the base. So there's another formula in logarithms that says the log base a of x is equal to ln x over ln a. And ln is one of the buttons that you have on your calculator. So I would rewrite this whole thing as ln 7 over ln 6. Oops, that's not a 6, that's a 6. Plus 8, and then I can plug it into my calculator to get the answer. And you don't want to round off until the end. Okay, so I'll leave that all in my calculator. And we get about 9.09 would be to the nearest hundredth. 9.09 would be my answer to this one. All right. So I hope that shed some light on these problems, and let me know if you need anything or any other help.